Welcome to this course on image processing and computer vision. So in this tutorial, we are having a look on image operations using pixel manipulation. So with the help of pixel manipulation, we are obtaining some changes in an image. So let's see what we are going to do in this tutorial. So basically, an image is nothing but it's an n-dimensional array. Means that it's a bunch of numbers. So what we are going to do is that we split a color image into its constituent channels. So a color image has three channels, which is R, G, and B, means red, green, and blue. So with the help of functions in OpenCV, what we do is that we split an image into its constituents. Means that I'm going to split my this particular image into its red channel, and green channel, and the blue channel. So we have a simple function for that, which is cv2.split. Now once we split all these into its constituent channels, the next thing that we do is that we use the cv2.merge function. So the merge function will actually merge all the constituent parts, means that it will merge red channel, green channel, and the blue channel into a single one. Means that with the help of cv2.merge, we will again obtain the same image what we have as our input. We will also try and understand what are the different functions in an image. For example, finding the shape of an image and finding the size of an image. So by the size, I mean that we will learn that how to find the total number of pixels which is in an image. And we will also learn how to find the data type of an image, right? And we will also be looking on to the type of image. So let's go on to our IDE and then look all these things. Firstly, the first thing I do is that I import my CV2 function, which is what we do in every tutorials. And then what I do is that I'm going to read an image. So for that, as well. So I'm just going and just reading one location of my. Just going to copy that and I give the name of the image. Do this. Now what we do is that let's resize it up to size. For that we have image equal to cv2 dot resize, and then let's keep the dimension as 600 comma 400. Now what we are firstly looking at, we will look to find the shape of an image. Shape means that what is the number of rows, what is the number of columns, and what is the channel of an image, right? That is what a shape means. And size, already I told you that size is nothing but the number of pixels contained in image. So let's go and print the, and for that you have function cv2.shape, function for your shape. Sorry, it's actually image.shape. We have print for size of an image, or you can just say that it's total number of pixels. For this, you have the function which is image dot. With the help of image dot shape and image dot size, you can basically find the dimensions of your image, and you can find the number of pixels in an image. And let's go and find the data type. So for that, we have the function. And first type the this function which is image dot d type. This is return your image data type. Let's go and print image type. This you have function as type image, and type this parameter you need to pass on the image. Let's see what we obtain here. So I just go and I just console here. So basically I get these out. You can see the shape of my image is 400 comma 600 comma 3. So basically 400 is the number of rows, 600 is the number of columns, 3 is my channel. Is that it's a color image. Now the moment I pass a 0 and then look, you may notice that the shape of image is 400 comma 600, meaning that your image is now a grayscale image. You have the total number of pixels for image dot size. So the total number of pixel size you can see here is this one. You get the total number of pixels. And then you have the data type. So as we already know that the data type of an image is unsigned integer of 8 byte. So that's what you get here. And the image type is nothing but it's actually a numpy array, a numpy n dimensional array. And that's what we got here. So basically for the shape, you can also go onto a variable explorer and you can see like the size is 400 comma 600. So let's not pass 0 here and then just look on. So you can see that the size of your image means that the shape actually, the function image dot shape is used 400 comma 600 comma 3. So you can also find it in your variable explorer. Now once we have done this, we have completed the first part of our tutorial. So let me just comment all these things out. Go to our formal operations on image, which is the splitting part, splitting my image onto the RGB and then merging it. Before that, let me show you the image. So that you have cv2.imshow. So this is what my image would look like. So it is what my image is looking like. So now what I do is that I just go and then I split my image. For that, you have the function which is cv2.split, cv2.split, right? So let's go and see how do we do that. So basically using cv2.split function. So just go and type print. So what this will do is that it will actually transform your image in the array of your image into three array, okay, into three different arrays. So it would be like in OpenCV we read it as BGR. So a single array would be converted into three multiple arrays, which would be representing your blue pixels, I mean the blue channel, the green channel, and the red channel. So let's see what does it return you. So you can notice in the console section that it would have transformed your array into three different parts. So this one you can see the first part of an array, this one is the second part, right? And this one is basically a third part. So it has actually splitted your dimensions or your array into three different arrays. So that is what we call as splitting it into constituent matrices or arrays. But then how different images look onto different channels. So let's also view that how did it look into green channel, blue channel, and the red channel. So for that, I'm just going to assign this particular split function to a variable which is bgnr. Once I do this, I have the freedom to actually view my bgnr channel. So what I do is that I just go and I just see my individual channels. So I have imshow for that. Finally, the red. I have just assigned this split function to the variable which is bgnr. and I've individually seen them. So it will individually display the three constituent channels, which is P, G, and R. So let's try and view this. So yeah, this one is my original image. This one is the red channel, and you can see that this one is my green channel, and you might notice that there is also a blue channel for me. So this one is the three channels. This one is the red, this one is the blue, and this one is the green. So your split function has splitted it into three channels, which is R, G, and B. And that is what the split function will do. Now what we do is that we use merge function, which means that it will merge these three channels to produce the original image. Now what we mean by channel is that it's based on the luminous, or you can say that it's based on the intensity, right? So let's go and just merge this. So for that we have the cv2.merge function as well. So let's just comment this out and let's look for merging the channels of. We have simply, for that we have merge function. So we have cv2.merge, and into a variable mr1, and then let's use cv2.merge, and then we have to use the rgnb. But you notice that the OpenCV actually uses BGR. But let's try and find if what if we type rgnb. So what does it displays you? Obviously, you won't get your original image because since OpenCV will read in the format of BGR, but you are passing RGB. So let's have a look onto this. So yeah, you can notice that your it's not getting original, it's looking something different since we have all passed RGB, but in OpenCV it reads as BGNR. The moment you pass BGR, you will get the original image. Then let's explore something. Let's type GBNR. You get this type of image. So it's quite a bit different, right? You can notice the different obviously. Now what we do is that we pass BGNR, and now you will notice that you will get an original image since it has done what? It has actually submerged your three channel into a single channel. It has merged the three channels of your image so that you will get the original input image. Yeah, you can now finally see that you have got an equal image. I mean the same of them. That is what your cv2.merge function would do. So basically what we have done is that we have actually seen different functions for different types. For image shape, we have img.shape. For finding the number of pixels, we have img.size. For data type, we have image.data, and finally the type of image can be seen by type image. And then we have splitted the images into its constituent channels, which is blue, green, and red. And with the help of merge function, we have finally merged that into a single image, which then returns our original image. This proves us that OpenCV reads it in the format of BGNR, not in the format of RGB. So you should always be careful with transforming the images into BGR channel. That is for this tutorial. I hope you have understood what exactly is the image operations using mix pixel manipulation, and with the help of split an image, how can we obtain these transformations. Thank you for watching.